Somewhere beyond the icy orbit of Pluto, in the outer reaches of our solar system, astronomers are looking deeper into the darkness than ever before. But every so often, the universe answers back with a discovery so bizarre that it resets everything we thought we knew. Imagine, for a moment, that you are peering through the most advanced telescope ever built, searching for subtle clues in the glare of the stars. Suddenly, there it is, a faint, flickering world, hiding in plain sight, and nothing about it makes sense. This is the thrilling reality that unfolded when the James Webb Space Telescope, humanity's most powerful cosmic eye, turned its gaze toward Alpha Centauri A, the Sun's near twin and one of the brightest stars in our sky. JWST's MIRI instrument, equipped with a coronagraph mask, pulled off a feat once thought impossible. It blocked out the overwhelming blaze of the star to reveal a world orbiting in its shadow, a world 10,000 times fainter than the star it orbits. But this is not just another far-off exoplanet. It's only 4 light-years away, orbiting a star so similar to our own that it almost feels like looking across the street at a cosmic neighbor. And what the telescope found was something truly extraordinary, a giant planet, probably with a mass close to that of Saturn, residing in the star's habitable zone, the very region where water might linger in liquid form, at least if this were a rocky planet. But this world is no Earth twin. It's a gas giant, and everything about it challenges our understanding of planetary science. The first clue that this planet was something out of the ordinary came from its colors. The images showed bands swirling across its atmosphere in shades of beige, orange, and deep red, a palette reminiscent of Jupiter, but painted in combinations and intensities never observed before. The contrast and brightness of these bands don't match anything seen in our own solar system. In fact, they don't even align with what scientists would expect from gas giants anywhere. The colors defy the rules, as if the planet is wearing a cosmic disguise, daring astronomers to figure out what's really happening beneath those turbulent clouds. What causes these alien hues? That question has set off a flurry of hypotheses. Some scientists suggest the planet's strange chemistry might be interacting with the fierce radiation from 2 closely orbiting stars, Alpha Centauri A and its sibling, Alpha Centauri B. Others believe there could be exotic compounds or cloud structures in its atmosphere, reflecting and absorbing light in ways that simply don't occur on Jupiter or Saturn. The fact that this giant world is orbiting within a chaotic environment, a system where 2 suns dance closely together, adds another layer of mystery. How could such a massive planet form, survive, and evolve in a place so turbulent? The very existence of this planet, as researcher Aniket Sanghi points out, forces us to rethink the basic rules of planet formation. Traditionally, astronomers believed that giant planets struggled to form or persist near binary stars, where gravitational forces create instability and chaos. Yet here, against the odds, is a Saturn-sized world calmly circling one of the closest sun-like stars to Earth. Its presence upends conventional models and opens up a galaxy of new questions. Adding to the enigma, astronomers were left with more questions than answers after the initial discovery. Follow-up observations with JWST in February and April of 2025 failed to spot the planet again. Was it a fleeting mirage, an artifact of data, a trick of the light? Or was the planet simply hiding, its orbit pulling it too close to the blinding glare of Alpha Centauri A for detection at those particular moments? Computer simulations suggest the latter. In half of the possible orbits calculated, the planet would have been lost in the star's glow, temporarily invisible to even the most sensitive instruments. If confirmed, this planet will be a milestone in the history of astronomy. It will be the first gas giant ever directly imaged around a star so similar to our Sun and so close to our own solar system. Not only is it closer to its host star than any other planet captured by direct imaging, but it also represents an unprecedented laboratory to study the composition, orbit, and climate of a world outside our immediate celestial family. The discovery has already electrified the astronomical community. The prospect of investigating a gas giant in the Alpha Centauri system, just a short cosmic leap from Earth, offers scientists the chance to probe the atmosphere, weather systems, and perhaps even the moons of a planet orbiting a star like our own. The opportunity is almost too tantalizing to believe. To unravel these mysteries, astronomers will need to combine the power of multiple telescopes. JWST will continue its vigil, hoping for another glimpse of the elusive planet as it swings back into view. Soon, it will be joined by the Nancy Grace Roman Space Telescope, slated for launch in the coming years. Roman will provide a new perspective in visible light, complementing JWST's infrared capabilities. Together, these observatories will allow scientists to measure everything from the planet's atmospheric composition to its reflectivity, potentially even revealing evidence of rings or exomoons. All of this is happening at a time when space telescopes are revolutionizing our view of the universe. The James Webb Space Telescope has already uncovered over 800,000 galaxies hidden in the abyss of space, and it's now pushing the boundaries of what we can see right in our own backyard. Every new observation brings us closer to understanding not just distant worlds and galaxies, but the very forces that shape the cosmos itself. And just as astronomers were marveling at the strange colors of this newfound giant, other cosmic surprises have emerged. Neptune, for example, has recently stunned scientists by lighting up in impossible colors, its bluish hue shifting into unexpected shades that have defied explanation. These discoveries are a reminder that the universe is full of surprises, waiting to be revealed by the next leap in technology and the relentless curiosity of the human mind. In this era of discovery, each new world, each unexpected spectrum, is a puzzle piece in the grand mosaic of the cosmos. And with telescopes like JWST and Roman leading the way, we are poised to uncover secrets that have eluded humanity for millennia. Just beyond the icy frontier of Pluto, an anomaly has emerged. A world whose colors, brightness, and very existence challenge everything we thought we understood about planetary formation. Spotted in the glare of Alpha Centauri A, this enigmatic gas giant is unlike anything astronomers have ever seen. The feat itself borders on miraculous. Imagine sifting through the blinding light of a star nearly identical to our Sun, searching for a faint, distant companion. That's the challenge that confronted astronomers using the James Webb Space Telescope. But thanks to JWST's mid-infrared instrument, equipped with a sophisticated coronagraph mask, scientists managed to suppress the overwhelming brilliance of Alpha Centauri A by a factor of 10,000. In that fleeting darkness, a faint, flickering world was revealed. This planet, orbiting in the star's habitable zone, immediately defied expectations. It's a gas giant, roughly Saturn's mass, but its colors are the true puzzle. While Jupiter dazzles with its creams and rusts, and Saturn's bands are subtle and subdued, this planet's atmosphere blazes with intense bands of beige, orange, and deep red, swirling in patterns never before cataloged. The contrast is so stark that it doesn't fit any known models of gas giant atmospheres. What could cause such unexpected hues? Theories range from exotic atmospheric chemistry, perhaps clouds thick with silicates, complex hydrocarbons, or even metallic compounds, to the influence of Alpha Centauri A's radiation, or gravitational tugs from its binary companion star. The planet's very presence, orbiting in a system with two closely separated stars, raises profound questions. Conventional wisdom holds that the chaotic dance of binary stars should disrupt the vast disks of gas and dust needed to build worlds. Yet here it is, a gas giant not only intact but thriving in a gravitational environment that, on paper, should be hostile to planet formation. This discovery forces scientists to reconsider the resilience of planetary systems and whether our own solar system is truly as typical as we once believed. But the mysteries only deepened. After the initial detection, further observations in early 2025 failed to spot the planet again. Was it a fleeting mirage, a trick of light, or simply hiding in the star's glare during those months? Detailed simulations suggest the answer is more mundane, yet no less fascinating. In roughly half of its possible orbits, the planet would have been too close to Alpha Centauri A for current instruments to separate the two. In other words, it's playing a cosmic game of hide-and-seek, revealing itself only when the geometry is just right. To solve this riddle, astronomers are preparing for a new era of coordinated observations. The James Webb Space Telescope will continue to monitor Alpha Centauri A, searching for the planet's return, and the upcoming Nancy Grace Roman Space Telescope will join the quest. Roman's ability to observe invisible light will complement JWST's infrared prowess, enabling scientists to probe not just the planet's atmospheric composition, but also its albedo, the fraction of starlight it reflects, and perhaps even the presence of moons or rings. If confirmed, this would mark the closest directly imaged gas giant to a sun-like star and the best opportunity yet to peer into the secrets of a world outside our solar system. Scientists hope to measure the planet's orbit with unprecedented precision, unravel the chemistry of its clouds, and even track weather patterns across its alien skies. Each data point will help refine our models, not just for this world, but for all exoplanets scattered across the Milky Way. Meanwhile, closer to home, another planetary mystery has captured the attention of NASA scientists, the elusive Planet 9. For years, astronomers have hunted for signs of a massive unseen world lurking at the edge of our solar system, its gravity subtly tugging at the orbits of distant icy objects. Now, fresh data has revealed bizarre motions near the Sun, movements that don't fit the gravitational dance of known planets. Could these be the fingerprints of an undiscovered giant, perhaps 10 times the mass of Earth, hiding in the darkness beyond Neptune? Or is something more exotic at play, like a primordial black hole or a swarm of yet unseen objects? To unravel these enigmas, astronomers are combining the sharp eyes of space telescopes with the brute force of supercomputers. Simulations can now trace the complex gravitational ballet of the solar system over millions of years, searching for the subtle signatures left by a hidden planet. Every new clue adds to the mounting evidence, but also raises new questions about the architecture of our cosmic neighborhood. And it isn't just new planets or hidden giants that are turning heads. Some of the most familiar worlds in our own solar system are behaving in ways nobody predicted. Neptune, for instance, recently lit up in impossible colors, baffling scientists across the globe. Using telescopes sensitive to wavelengths beyond human vision, researchers detected shimmering bands of light in hues never before associated with the ice giant. The exact cause remains a mystery. Perhaps changes in atmospheric chemistry, shifting storm patterns, or even unknown processes deep within Neptune's core. Each of these discoveries, from the bizarre hues of a world around Alpha Centauri to the spectral glow of Neptune, is a reminder that the universe is far stranger and far more marvelous than anyone imagined. Every observation is a step deeper into the unknown, a data point that forces us to rethink the rules of planetary science. And as our instruments grow sharper and our reach extends further, the cosmos continues to reveal new surprises, each one a testament to the boundless curiosity that drives humanity to explore. What lies ahead is not just a catalog of new worlds, but a fundamental transformation in our understanding of how planets, stars, and entire solar systems form and evolve. In the coming years, as telescopes like JWST and Roman work in tandem, we may finally uncover the hidden mechanisms that paint planets in impossible colors, forge giants in binary systems, and sculpt the architecture of the heavens themselves. The adventure is only beginning, and every strange discovery brings us closer to piecing together the ultimate puzzle, the story of our cosmic origins. What makes this new world beyond Pluto so captivating isn't just its proximity or the fact that JWST managed to spot it amidst the blinding glare of Alpha Centauri A. It's the kaleidoscope of colors painting its atmosphere, hues and patterns that outright defy our expectations. Beige, orange, and deep red bands twist and swirl across its surface, a spectacle so unearthly that even seasoned astronomers are left in awe. These colors suggest complex atmospheric chemistry or processes we haven't encountered before, hinting at clouds of unknown compounds, exotic weather phenomena, or perhaps even interactions between the planet's two suns that we're only beginning to consider. The challenge of directly imaging such a faint world, especially one huddled close to the blinding light of a sun-like star, is a testament to just how far our technology and ingenuity have come. The MIRI instrument aboard JWST, with its coronagraph mask, functioned like cosmic sunglasses, carefully blocking out the overwhelming starlight to reveal the planet's delicate glow. It's an achievement once thought impossible, proof that with each new leap in observation, the cosmos reveals yet another layer of its secrets. Secrets. Yet the mystery only deepens. After that first tantalizing glimpse, follow-up observations failed to recapture the planet, suggesting either a highly elliptical orbit, or perhaps even that the planet was nestled so close to Alpha Centauri A as to be invisible against the star's light for much of its journey. This has ignited a flurry of simulations and orbital models as scientists race to predict when and where the planet will next reveal itself. The very fact that its presence is so elusive, hiding in the glare, only adds to its mystique. Meanwhile, the implications ripple outward. Finding a gas giant in the habitable zone of a binary system, where gravitational forces are in constant chaotic tug-of-war, challenges our models of planetary formation. How did such a massive world assemble and survive in such a turbulent environment? Could there be moons orbiting it? Perhaps rocky satellites warmed by tidal forces and basking in the light of two suns? And what about the composition of its atmosphere? Could those unusual colors be signatures of elements or molecules we've never seen before in a planetary context? These questions are at the heart of what makes space exploration so thrilling. Each new discovery, each unexplained observation, acts as both a puzzle and a promise. With the Nancy Grace Roman Space Telescope preparing for launch, the next chapter is about to unfold. Roman's powerful visible light capabilities will allow us to see these worlds in a new spectrum, complementing JWST's infrared prowess. For the first time, we'll be able to measure not just the heat radiating from these planets, but also the way they reflect starlight, their albedo, and perhaps even catch glimpses of weather patterns unfolding in real time. As these telescopes work in concert, they'll transform our ability to characterize exoplanets. We'll be able to identify atmospheric components, like water vapor, methane, or ammonia, by their chemical fingerprints. This will reveal not just what these worlds are made of, but how they change over time, how their climates function, and whether any of them might be truly habitable. And this isn't happening in isolation. The discovery of a bizarrely colored planet orbiting Alpha Centauri A comes on the heels of other cosmic surprises. Neptune recently lighting up in impossible colors, hinting at unexplained atmospheric phenomena, mysterious motions near the Sun that have reignited the search for the elusive Planet 9. Even supercomputers are now stepping in, simulating planetary systems and cracking codes that once belonged only to the pages of science fiction. We're living in an era where the line between the imagined and the real grows thinner with each passing year. With every new observation, telescopes like JWST and Roman are rewriting our textbooks and expanding the frontiers of what's possible. The universe is revealing itself not as a static, predictable place, but as a dynamic, ever-changing arena filled with surprises and wonders at every turn. The discovery of this new world beyond Pluto, with its impossible colors and mysterious orbit, is a reminder that our solar neighborhood is far from ordinary. It's a cosmic invitation, one that urges us to look closer, to ask deeper questions, and to keep searching the skies for the unknown. As we continue to explore and unravel the mysteries of the cosmos, one thing is certain: the story of our universe is still being written, and every discovery brings us closer to understanding our place within it. If you enjoyed joining us on this journey beyond the edge of the known, make sure to like this video and subscribe for more content like this. The universe is vast, and there's so much more waiting to be uncovered.